Good morning, Federal Council. We are here to pitch a solution for the transportation hub.
Experiment 523, Experiment 626, Experiment 344, Experiment 276, and Experiment 221.
As we all know, these experiments are very dangerous and difficult to contain.
Our company, Divvy It Up Incorporated, based in Honolulu, Hawaii, United States, Earth, Milky Way, have created a complex plan to handle and transport the experiment. We would now like to present a demonstration of our planned journey containing the highlights of the path and the difficulties and how to deal with these difficulties. Over the course of our trip, we will be covering many galaxies or systems of millions or billions of stars, gas, and dust held together by gravitational attraction. There are three types of galaxies. Spiral galaxies are classified by three main components: a bulge, disk, and halo. The bulge is spherical and found in the center of the galaxy, which mostly contains older stars. The disk contains younger stars. The halo is loose and spherical and can be located around the bulge and the disk containing old clusters of stars. Elliptical galaxies are shaped like an elongated sphere. In the sky, they are seen as two-dimensional, although not actually. They are elliptical or oval-shaped disks. The light is smooth with the surface brightness decreasing as you go further out from the center. Irregular galaxies have no regular geometric or symmetrical structure. In these galaxies, there are several different types of stars we will pass. White dwarfs have the highest temperature, followed by blue giants, red giants, and red supergiants. Our ship will be made out of tungsten with a melting point of 3,695.15 degrees Kelvin. So, we may not pass, in any situation, white dwarfs or blue giants, unless we are a certain distance away so its full heat does not affect the ship. Some situations, we may pass the mid to low temperature red giants. We may pass all red supergiants. In the main sequence, we may pass average to low temperature stars. If the temperature is below 3,695.15 degrees Kelvin in the location we would like to pass through. However, the red giants and supergiants we may pass have extremely high luminosity. There will be no windows or any opportunity to see the space journey for the prisoners. However, the crew will have to wear special radiation blocking suits and sunglasses at all times during the journey. We will be able to measure the luminosity and calculate the temperature using a spectroscope. We can also calculate the size of the star. However, as long as we keep a logical distance away from the stars, we are cleared to pass. Our ship can handle the heat. According to Bing Dictionary, a supernova is a catastrophic explosion of a large star in the latter stages of stellar evolution, in a resulting short-lived luminosity from 10 to 100 million times that of the Sun. Using this information, it is clear to say that we may, in absolutely no circumstances, come close to supernova. However, upon investigation, it is not seen that we will run into any supernova. Black holes are a region of space having gravitational fields so intense that no matter or radiation can escape, according to Bing Dictionary. We must use the escape velocity formula to calculate how we may need to speed up when approaching a black hole, but we must stay well away from the event horizon or the point of no return. The distance depends on the size of the black hole. However, our path will avoid the center of the galaxy, which is where black holes are their largest and tend to be present a large percentage of the time, although we do have some idea of stars we may pass. Firstly, we will pass stars of the Sagittarius constellation, which contain a number of deep sky objects. We will have to avoid the Pistol star in this constellation, which is a blue hypergiant and is extremely luminous. This star may exceed the capabilities of our ship. These are some of the stars that make up the constellation. Secondly, we will pass the stars of the Triangulum constellation. However, there are no first-degree stars in this constellation. It should not be a problem for our ship to pass. These are some of the stars that make up this constellation. The final constellation we will pass is the Andromeda constellation. We will have to avoid Alpheratz, which is too hot for our ship to closely pass. These are some stars in the Andromeda constellation. As for space debris and various particles in the nebulae, our ship walls, made with 3 meters of solid tungsten, should stand up perfectly to the average space diffuse we are likely to encounter. Earth is in the Milky Way galaxy. This map shows where this is located in relativity to our path and destination. Andromeda, our destination, is 2,500,000 light years away. This is an incredible distance and safe enough to harbor the prisoners. We will be landing on asteroid DIVV52YITUP, an asteroid which is 900 kilometers in diameter, which is a mid-sized asteroid. We choose to land here because comets are not understood in depth and are not made of solid rock. And most meteoroids are smaller than a grain of sand, and our ship weighs almost 29 million kilograms. These two options would be impossible. These asteroid landings was our only choice. Our ship is very dense, most of the weight comes from the tungsten walls, so it is very compact and should comfortably land on the surface of asteroid DIVV52YITUP. This is an outline of our journey. Our journey starts here at the Milky Way galaxy. We then run into the Omega Nebula, which should be no problem for our 3-meter tungsten wall. It is a slanted downward right movement in relativity, looking at the map provided, to the next galaxy, the Sagittarius Dwarf Elliptical Galaxy. Then it is a small leftward movement to the next galaxy, the NGC 6882 Irregular Galaxy. Next we push forward in an upwards leftwards direction to the Triangular Spiral Galaxy, which is our last stop. We push directly leftward to arrive in Andromeda Galaxy, in which asteroid DIVV52YITUP is located. Our destination asteroid is located in the outer portion of Andromeda as shown. This way, we are in less risk of encountering the infamous center of the galaxy, massive black hole that many galaxies are said to have. The speed we have to go when passing the medium star is calculated using the escape velocity formula. In this formula, the velocity part is a misnomer. The quantity is a speed. Regardless, we calculated that we will have to travel 617,642.8202 meters per second if we were to travel near the surface of a medium-sized star like our Sun. However, this number is padded due to the fact that we will not plan to go very close to the star's surface. However, this is a good speed to go for safety reasons. Using the same formula and a spectroscope, you can calculate if a faster speed is needed should we encounter a larger star or obstacle. We will now describe how we will handle the prisoner samples we are given. Please note that all cells have a feeding compartment that locks shut. This will also be used to replenish the cell's air supplies periodically throughout the journey. We have also added blank cells to the ship, which only contain the silicon and tungsten walls. Special needs will be addressed prior to the journey, and Divium Incorporated is given more experiments to handle. Please also note that the cells are lined with a small layer of acid-resistant titanium alloys. The tungsten and silicon walls surround the cells, but in these models, the front walls are removed to view the interior. Experiment 523. This experiment will be separated into bits of ice, and each one of these will be stored in separate plastic, insulated, titanium-enforced cylindrical containers. These will be floated in super chilled. If distilled water is chilled under freezing point and handled carefully, it will not become a solid. If an ice bit tries to escape the container, the water will instantly freeze into ice, trapping it. Once the prison transporter reaches the destination, the bits can and will return to its original form. If the water freezes due to the removal of containers upon landing, there is a heating function that may only be accessed outside of the cell in the pilot seat. Experiment 626. This experiment will be submerged in water. However, it will be supplied air containing various gases, since the gas that this experiment needs to live is unknown. It will have 360,000 pounds of osmium, the most dense and stable element known, strapped onto its back. This weight was derived because the experiment weighs 120 pounds according to Wikipedia. It will still survive because it can rest on the ground, however, it cannot go anywhere. The water the experiment will be submerged in will be contained in a titanium fish tank type structure with an outer layer of plexiglass surrounding it. This fish tank containing regular liquid water will be surrounded on all sides by super chilled water similar to experiment 523. If the experiment escapes the regular water, he will immediately reach a super chilled water and it will simply freeze on contact, trapping the experiment. Experiment 344. This experiment's lower body, that is from its forehead down, will be a normal titanium-built plexiglass enforced cell. However, a layer of pure diamond will be fitted airtight to the experiment right at the start of the forehead. Above this, the walls will be covered with Yale University Laser Light Absorbent Material, LAM, which will absorb the experiment's cloning laser beam, rendering it useless. Experiment 276. This experiment will be put in a standard cell, however the tungsten walls will be twice as thick. Inside a cell, it will be placed in a portable plexiglass container that can be used to transport it in and out of the ship. Inside the container will be vegan food, so nothing is living, and a small square that is only gas permittable. Once inside the ship, a tube will provide a slight air draft into the cutout, as to prevent from the experiment from escaping from this cutout. Experiment 221. This experiment will be simply placed in an airtight cell. The food and air openings will be extra insulated. There will be a layer of rubber added in addition to the silicone. These two materials are both insulators and will not allow the current to pass through. If the current gets too intense, a conductive wire can be added to flow out of the cell, airtight and insulated, to the engine room, where it will be used to help power the ship. This will only be used if the current gets too intense.